Okay, and here's one of the last questions that was asked, and I want to share this with you because there's so many resources you have available to you that are online that will make your life so much easier. If you happen to have a graphing calculator similar to this one, which is known as the TI-8384 calculator, it's an actual, looks very much like this, and they sell them at I guess Office Depot or Office Max. They sell them at Walmart and Target as well. I know that I purchased my actual calculator for about $40 on Amazon. So, and that's not a bad price at all. If you were to use a calculator like this, you can actually run several of these tests. So if you notice, it says edit calc and test on top. So with the arrows, you would move over to test, and then simply drop down. There's where you see intervals after the Z interval, T interval, and so on. All of these are confidence interval calculator components that you can use. So that is available to you. Okay. The in this case, I'm going to also show you with the formula. So let me pull up the OneNote to talk to you about confidence intervals. And so what I need to take away from confidence intervals is that in this case, in this particular example, you have been given a mean, and it says the mean diastolic blood pressure for a random sample of 150 people was 81 milliliters of mercury. If the standard deviation of an individual blood pressure reading is known to be 10 millimeters, find a 95% confidence interval for the true mean diastolic blood pressure. And then it says complete the following below, and you're putting the lower limit and the upper limit. So this is why in the formula, and I'm going to write a generic version of it. So you have a mean, and this is plus or minus the critical value times the standard error. Okay? And in this case, you're given a mu. I'm sorry, this would actually be an x bar because it's a random sample. X bar, which is equivalent to 81 milliliters. So this is 81. I don't need to worry about the units. The reason I'm using x bar is because in the question it says there's a simple random sample where n, the population size or the sample size, is 150. Then they give you the actual population standard deviation of 10 millimeters. Now again, you don't really need that. Just the 10 is sufficient. And they want a 95% confidence interval. So these are all givens in your question. Okay, so you can just extract that from the question. Now, the confidence interval has an upper and lower limit because of the plus minus. This is where you get your upper lower. Obviously the plus will give you the upper, and the minus, using the minus will give you the lower. So in essence you're doing this twice. So if I'm doing the lower confidence, I'm going to do 81 minus. Now it's 95% confidence. The critical value is known as the critical Z value. So it's basically alpha split in half. Since this is 95%, alpha is 5%. But because it's a confidence interval, we split it in half. So we give the lower half 2.5% and the upper half 2.5%. One of these takes in account the 95% attached to it. So in other words, this is actually 97.5%. So using our function inverse norm, or in your Excel you would use norm inverse, norm S inverse, you're going to put in 0.975, and that's going to give you the critical Z value that you're looking for. So let's see, inverse norm 0.975 with a mu of 0 and a standard deviation of 1. I'm at a Z-score of 1.96 rounded to two significant figures. So in this case, this value here is 1.96, and I'm going to multiply that times the 10 millimeters over the square root of 150. And again, remember, this is the standard error. Standard error, by definition, is the population standard deviation over square root of n. Okay? So once you do this, the upper confidence looks very similar, except you're going to use plus 1.96 and then 10 over square root 150. Now you plug in your values into your calculator. You simply work them out, and your answer for the upper and lower respectively, and we use a z because of the fact that we have 150 and a 150. So we should have a lower confidence, which is the first value you put in, of 79.4, and an upper confidence of 82.6. Now I'm putting parentheses around these just to sort of draw a line for you, but your final answer, if you were doing this officially, would look like this, where you simply are writing down the upper and lower confidence as such. I want you to note that if I were to add these two numbers, so if I added 79.4 plus 82.6, I would get 162, which if I divided in half would give me 81. Hence the mean is always right in the middle of the two. The distance from these respectively is what we refer to as the margin of error. And it is the same on both sides. It is a distance, so it's always positive. So in this case, we could see that if I were to subtract, for example, 82.6 minus 81, I would have a difference of 1.6. So my margin of error for this data set is 1.6. Notice that if I were to take 81, for example, and I subtracted 79.4, I would get 1.6. If I take 82.6 and I subtract 81, notice that I get 1.6. And yes, I have to do this in a manner that this will always be a positive value. Okay? Now, in this case, your answers are already here. This is your final answer. Your upper and lower confidence, respectively, are stated right here. Now, what I want to show you is a couple of tools. And so I'm going to go out to the internet and I'm going to look for a confidence interval calculator. And I want you to notice how easy this is going to be for you. This is Math is Fun, and it's asking me how many in the sample, as we know that our sample is 150. The sample mean is 81, and the standard deviation is 10. Notice that it's 95% confidence, and look at your answer right here. So, can't get any easier than that. If you want further explanation, this is what I just covered with you, so you can take a look here. And they give you lots more. If you just keep clicking, it'll give you other intervals, such as the t interval, or one prop t int. Alright, so lots of fun tools, and best of luck.